Steel bar 2.4 meter long and 30 mm square is elongated by a load of 400 kN. If Poisson's ratio is 0.25, find the increase in volume. Assume Young's modulus is equal to 200 kN per mm square. This is the given problem statement. So, according to this problem, first we will write the given data. The steel bar 2.4 meter long means it having a length of 2.4 meter, that is represented by L. L is equal to 2.4 meter. 2.4 meter and 30 mm square. So it is a square bar. So that the side of the square is given is 30 mm. Side of the square is equal to 30 mm. Is elongated a load of 400 kN. Means the load is given. Load is represented by P. P is equal to 400 kN. 400 kN. And the Poisson's ratio is 1 by m. 1 divided by m is equal to 0.25. M is also 1 by m is also given. And find the increase in volume. Assume E, Young's modulus. E is equal to 200 kN per mm square. So, according to this given data, we need to change, if it requires, we need to change the unit of the given values. So, here 2.4 meter is given, the side is given in the terms of mm, and also Young's modulus is also given in terms of mm. So that we will convert 2.4 mm into a, or meter is converting into, or in terms of millimeter. So that L is equal to 2.4 into 10 to the power of 3 mm. This is the length of the steel bar. Then the side of the square is given. According to this, we can find out the area of the square bar. So that area of square bar is equal to 30 into 30. So that 900 mm square. This is the area of the square bar. And P is given in terms of kilonewton. So here also is mentioned in kilonewton. So that we don't want to convert kilonewton in terms of newton. Next, the 1 by m, Poisson's ratio, 1 by m is equal to 0.25 is given. But we can find out the value of m is equal to 1 divided by 0.25 is equal to 4. The value of m is 4. So first we will, here we need to find out increase in volume. Increase in volume means change in volume. So delta V is we needed. Let us consider the original volume. Here we don't know the original volume of the square bar. First we need to find out the original volume of the square bar. So original volume of a bar. Volume is nothing but area into length, means L into A or A into L. Here we know the value of L and also we already find out the value of A. So that L is 2.4 into 10 to the power of 3 in terms of mm into 900. By solving these values, we will get 216 into 10 to the power of This is the original volume of the ball. So we need to, we know the value of changing length. According to the longitudinal strain, we can find out the value of L. So that longitudinal strain is equal to delta L divided by L. Delta L divided by L is equal to, we can write it as P by AE. So Young's modulus is equal to, we are rearranging this equation by using E. Young's modulus is equal to stress divided by strain. So strain is a longitudinal strain. By rearranging this equation, strain is equal to sigma divided by E. Sigma can be written as P by A and epsilon is represented by delta L divided by L. So this equation can be rearranged as a delta L divided by L is equal to P by AE. So substitute the values of delta L divided by L as well as P divided by AE. So here we can find out the strain value by using Young's modulus. So that delta L divided by L or nothing but epsilon. Epsilon is equal to P. We know the value of P. P is 400 kilonewton or kilonewton we are converting into in terms of Newton. So 400 into 10 to the power of 3 Newton divided by area. Area we already find out 900 mm square. 900 into E. We know the value of E. E is equal to 200 kilonewton. So 200 kilonewton is converting into 200 into 10 to the power of 3 newtons. So substituting the values or simplifying these values, longitudinal strain epsilon of L is equal to, or delta L divided by L is equal to 2.22 into 10 to the power of minus 3. This is the longitudinal strain or nothing but delta L divided by L. By using the relation of E and then Poisson's ratio, we can find out the volumetric strain. The volumetric strain is denoted as delta V divided by V is equal to delta V divided by V is equal to delta L divided by L. Delta L divided by L is nothing but epsilon. Epsilon into 1 minus 2 divided by M. So substituting the values, we can find out delta V divided by V. Delta V divided by V is equal to changing length divided by original length, means delta L divided by L is 2.22 into 10 to the power of minus 3 into 1 minus 2 divided by the value of M is 4. M is equal to. So substituting these values or simplifying, we will get 1.11 into 10 to the power of minus 3. This is the change in volume with respect to the original volume. So volumetric strain we are getting. Now we need to find out change in volume. Change in volume can be calculated as delta V divided by V is equal to, here we already find out the value of volumetric strain, delta V divided by V. So delta V divided by V is equal to 1.11 into 10 to the power of minus 3. So that delta V is equal to 1.11 into 10 to the power of minus 3. We know the value of V. V is volume of area. The volume is 260 into 10 to the power of 4 into 10 to the power of 4. Delta V it becomes, means substituting or simplifying those values, we will get 2397 2397.6. Volume is mm cube. This is the value of change in volume.